All right, guys, welcome to lesson 9. We are going to keep working on our exponentials intro. Let's get ourselves moving. All right, so this is the beginning of our table of contents, and here's where we're at. We're going to actually use 2 pages today. So we are going to put some information on 23 and 25. All right, go ahead and pause and get this down on page 23. All right, so you already kind of know some of this. The big deal here, guys, is we need to know about our equation. This is what we're going to be focusing on. And there are 2 parts to that equation, the letter A and the letter B. The A is our starting value, and the B is the multiplier. So now look, if the B is bigger than 1, then we're going to have what's called a growth, and you're going to have a graph that looks something like what you see on the right. If the B is in between 0 and 1, like say 1/2, 0.5, 0.7, those kinds of numbers, it's going to look like the second graph here. That's called a decay. So if you think about it, if you have something and you're cutting it in half, it's just going to keep getting smaller and smaller, and that's what happens as it moves to the right. Every cut just keeps making something half the size. But it will never go to 0. Because if you cut something in half, there's always half of it left. So that's why that graph just kind of, as it keeps moving right, just stays over the x-axis. All right, now, down here I got a table, and it's 0 through 3, and we can see the numbers for the y values. They are multiplying by 2. It's doubling, 5, 10, 20, 40. So since it's doubling, that tells us that the multiplier is 2, which goes into the B position. And the starting value is always the x-intercept. Or sorry, is the y-intercept, not x-intercept. And that's this one right here, where your x value is 0. That's always the starting value, so it'll be 5. And this is how I get this equation down here at the bottom. The 5 went into A position because it was the starting value. And the 2 went into the B position because it was doubling. That was the multiplier. And you just have to get used to where this is. And notice there's a little x that's on the exponent of the multiplier. That's what makes something exponential. All right, now, what if you got a table? You know, we could fill in the rest of this. And I wanted to show you this with some weird numbers so that you can see that your multiplier doesn't have to be just always a nice pretty number. So now when you look at this table, you can see that the starting value is missing. You can see that the first value is 6 and the second is 4.2. It's going down. You know, the third one is 2.94. So this is a decay. So this tells us that our multiplier is going to be in between 0 and 1 because your y values are getting smaller. And a lot of times it's going to be 0.5, so you can easily see it. But this one you can't see. So how do we figure out the multiplier? Well, what we do is we divide backwards. We're going to go 4.2 divided by 6. Because remember, division is the opposite of multiplication, so we're going to go the opposite direction. So 4.2 divided by 6 is 0.7. So that's what we were multiplying going down is 0.7. So we're dividing going up. So if you do 6 divided by 0.7, you're going to get 8.57. And that is our starting value. So the multiplier was 0.7. And the starting value was 8.57. So we can easily see our equation there. All right, so that leaves us now with this situation. So we're going to make our equation based off of this piece. So let's see what we got. You've got a virus has gone into someone's fishing lake. Oh, this isn't good. And you have an estimated 1,800 trout in the fish. So that's our starting value. But what's happening here is that 1/3 of the fish are dying each week. So you lose 1/3. So what we're going to do is we're going to make a little table here. So we're going to have week. And at week 0, there were 1,800 fish. So fish in pond. Now what happens is 1/3 die. So what I'm going to do, and I can just kind of do it down here on the bottom, I'm going to do 1,800 times 1/3. So I'm going to, you can do this in your head or use your calculator. I figure a lot of you will use your calculator. 1,800 times 1/3 gives us 600. So 600 died in the first week. So that means that 1,200 were left. All right, and then on the second week, we're going to do 1,200 times 1/3. So I go 1,200 times 1/3, and we get 400. So 400 more fish died. 1,200 minus 400 is 800, because that's how many fish are left. And this is asking us to take it down to week 6. So we're just going to continue this pattern. So now I'm going to do 800 times 1/3. So I can find out how many fish are dying each time. Oops. And I get 266.67. Now look. We can't have just partial fish alive. So you just kind of round it to the nearest whole number. So there's 200 and, whoops, I made that wrong. Look at me. I was writing the number of dead fish in there. See, I almost made a simple mistake. 267 is what died. So if you do 800 minus 267, so you go 800 minus 267, and you get 533. It's working our way down. So we're going to take 533 times 1/3. And we get 177.66 or 178. So now I need to do 533 minus 178, and we get 355. Fish still alive, so it's shrinking. So now 355 times 1/3. And this gives me 118.333. That rounds down to 118. So 355 minus 118 leaves me with 237. All right, so now I have 237 times 1/3. And we have 79 fish that died. So 237 minus 79 gives me 158 fish left. Haven't done anything with the equation yet. I just went down the little line here. All right, now if I want to write the equation, I'm going to need my A and B. My starting value, which we know is 1,800. Now to get the multiplier, we're going to need to divide backwards. Pick any number that you see on the right side and divide by the prior number. So I'm going to go this way. So I'm going to do 533 divided by 800. So let's see what that gives us. 533 divided by 800 equals 0.6666. Or 0.67. That kind of makes sense, guys. That's 2/3. So if you think about it, 1/3 of the fish were dying, so 2/3 were living. And our table is representing the living. So our equation is going to be our starting fish number of 1,800, our proportion that's living, 0.67, to the x power. Now, theoretically, will the trout population ever reach 0? Well, we're going to keep taking a third away, and eventually you're going to get down to that last fish. And that last fish, someone could say, hey, look, that last fish will never die. But in theory, it's probably going to get sick too and end up dying. So I would be cool with any argument someone made on that. That's a good little talking problem. All right. Here's what you've got to work on. Guys, I have a little Google slide for you to do. And then 2 problems out of your book. And then please, hey, look, we're at the end before our break. Make sure you've taken all the quizzes and you've completed all your work. Do that ASAP, because if you wait till we come back from break, you're going to have a really hard time, especially with the quizzes. All right, so, and I've made all the quizzes where I'm giving you the highest score. I'm no longer averaging. All right, guys, good luck, take care, stay safe.